This video is to remind you of the differences between factors and multiples before you complete the activity for this station. You might remember us saying at the beginning of the year that a factor is a number that you multiply together to get a product or a multiple. So for example, the number 3 times 5 gives you the product of 15. So the factors are 3 times 5 in that case. 3 and 5, or 5 and 3 are the factors that create the product of 15. And then it looks like I have the disappearing ink on there, so my apologies. Also, something that you might remember about factors is that there's a finite number of them, which means there's a certain number of factors for each number, unlike multiples that go on and on forever. Another attribute of a factor is that the number of factors that a number has determines if a number is prime or composite, and we'll talk about what prime and composite are again later on in this video. Another time you might hear factor is whenever we tell you to find the greatest common factor. And I know I always tell my kids the greatest thing you can do to a fraction is simplify it. And the reason that I say the greatest thing you can do to it is because I want you to remember that you have to find the greatest common factor of the numerator and the denominator in order to simplify that fraction. So moving on. Some attributes of multiples are that they are just the numbers that you say when you skip count. So for example, if I were listing the multiples of 5, the multiples of 5 are 5, 10, 15, 20, 25, and so on. That leads me to my next point, that multiples are never ending. I can continue to list the multiples of a number forever and ever. Another time you might hear us say multiple is whenever we ask you to find the least common multiple, and you're going to do that when you are trying to find a common denominator in order to compare fractions or add or subtract them. So now that we've remembered the characteristics of factors and multiples, we're just going to practice, and I do need to figure out how to, hang on, I'm going to pause. Sorry about that. I had to make sure that I had the regular pen on so that way that my pen wasn't disappearing on you. We're going to practice finding the factors of 18. Now, the best way to find factors is just to know your facts. We hope, Miss Minton and I really hope that by now you have all of your facts committed to memory, but if you don't, you need to get on reflex math. In order to find factors of numbers, you're always going to start with 1. And it makes sense to go in a logical order, which means starting at 1 and then trying 2, and also remembering to connect with that factor rainbow. We know that 1 is an important number because 1 is a factor of every single number. So every list should always start with 1. What about 2? Is 2 a factor of 18? Yes, it is. 2 times 9, I know that because it's a basic fact. I also know that 2 is a factor of 18 because 18 is an even number, so all even numbers have a factor of 2. I also know that 3 times 6, factor times a factor, will give me a product of 18. I know that 4 is not a factor and 5 is not a factor. And now I've arrived back here at 6, which means I can stop. I have now listed all of the factors of 18. That's just one strategy for finding the factors of a number. Another strategy would be to use an array. I always encourage my friends that have not committed all of their facts to memory to make sure that you're drawing an array in order to check, guess, and check for finding factors of numbers. Remember I told you that 1 is a factor of every number, so I know that if I drew a 1 by 18 array, that I would make a perfect rectangle or square with nothing hanging off of the sides. Next, I would try 2, and I've got a 2, 4, 6, 8, 10. Sorry, this is not making the best example here. It's hard to see. I'm going to try that again. You can fast forward through this part if you don't use this strategy, but if this is something that you think might be beneficial to you, stay here and watch it. 6, 8, 10, 12, 14, 16, and 18. And I can see here that I have made an array and the dimensions are 2 by 9. Those dimensions serve as my factors as well. Next, I would try 3. 1, 2, 3, 6, 9, 12, 15, 18. I made another perfect rectangle here in this case. So I know that other factors of 18 are 3 and 6. Here's an example of one that doesn't work. We know that 4 is not a factor of 18. If I made an array of 4, 8, 12, 16, 17, 18, I can see that I did not make a perfect square or rectangle here. Again, the same thing would happen with 5. I know 5 is not a factor of 18 because I know 5 numbers that have 5 as a factor end in the number 5 or 0. The last thing I want to talk to you about is the difference between prime and composite. A prime number is a number that has numbers that have only 2 factors, 1 in itself. And I remember us drawing this in our journals earlier in the year, and we made sure to capitalize the I, the M, and the E. That I reminds me of a number 1. And me should remind you of itself. Examples of prime numbers are numbers that only have 2 factors, 1 in itself. Whereas a composite number is a number that simply has more than 2 factors. So when we were finding the factors of 18 earlier, we could come to the conclusion that after seeing that the number 18 has more than 2 factors, that it is a composite number. And finally, listing the first 5 multiples of 4. If you did that together, let's do that together. The numbers you say when you skip count: 4, 8, 12, it's funny looking too, 16, and 20. And remember that we always end our list of multiples with this ... to remind us that it continues to go on and on forever.